Hi, good day, everyone. Welcome to our YouTube lessons. And today we'll be looking at Gay-Lussac's law. Um, some persons requested for this video, so I decided to make it for them. So, um, Gay-Lussac's law is actually a concept that's common to both O level and some part of A level. So, for those of us writing UTMA, or you popularly call Jamb, um, WAEC examination, or WASIL, NECO, and Co. This is a concept to be very, very, very useful to you. Okay, and the law states that if a mixture of a gas, let's say A and B, chemically react together, they do so in ratio of their volume of the reactant. So what do I mean? If A and B should react to give C, it therefore means that one volume of A react with one volume of B to give, let's say 2C, for instance, to give two volume of C. So they do so in ratio of their product and with ratio of their reactant, pardon me, and with respect to their product. So that is Gay-Lussac's law. That is Gay-Lussac's law. So Gay-Lussac's law is known as the Gay-Lussac's law of combining volume. Now, but how will the question normally come on Gay-Lussac's law? The question comes like, calculate the volume of the residual gas. You will see this. Calculate the volume of gas remaining. Calculate the volume of gas left. So when you see questions like this, they are on Gay-Lussac's law. They are on Gay-Lussac's law. So let's quickly tackle this one. Let me quickly show you the technique in solving Gay-Lussac's law question. Said 50 cm cube of hydrogen are sparked with 20 cm cube of oxygen at 100 degrees Celsius and 1 atm. The volume of the remaining gas is now let me quickly tell you what it means. Now, first of all, for Gay-Lussac's law, we're looking at combination or a chemical reaction. So hydrogen is reacting with oxygen, it is sparked. Now when hydrogen is sparked with oxygen, it is constant that we get H2O. Okay, now and because it's at 100 degrees Celsius, so this H2O will obviously be gas. Yes, obviously be gas. That means it cannot be liquid. That's why below 100 to it to be liquid. So now we have hydrogen gas, oxygen gas. So, but we have to balance. To balance this equation, I have to put a 2 here. I have to put 2 here. Yeah, the equation is then balanced. Yeah, then very balanced. So the question is now asking us, what is the volume of the remaining gas? The volume of the remaining gas. Now, for detail's sake, I would like to do adjust my board a little for detail's sake. I would like to adjust a little. Okay, this is for this sake. I would like to adjust because I need the space. So now let me put the reaction here. We have 2H2 gas plus O2 to give me 2A2O. Yes. Now that's how it look like. That's how it look like. So now what we normally do is that we take the ratio. What's the ratio? 2:1:2. That's the mole ratio or the volume ratio. Now we say before reaction or before spark, please follow the method I'm using. Before spark. Now before spark, how many things were given? 50 cm cube was sparked, sparked with 20. Now before spark, we had 50 cm cube here, and this guy, oxygen is 20 cm cube. Now, but water has nothing before spark. Okay, now how do you now get after spark? How do you get after spark? After spark means after reaction. So what are the things that have reacted? Now we do something very important. Now see what we do. You tend to check which of the gases is limited. Now what do I mean? For instance, now the ratio is 2:1. So it therefore means that 2:1. Let's watch. It therefore means that if I'm taking 20 as the standard, 20 will require 40. So that means if there's 20 oxygens to react, 20 oxygen will require 40 oxygen, 40 hydrogen, because it's 1:2. And if you check very well, do we have up to 50? Do we have up to 50 cm cube of hydrogen? Do we have up to 40 cm cube of hydrogen? Pardon me. Do I have up to 40 cm cube of hydrogen used for this spark? Yes. even more. It means that hydrogen is in excess. Hydrogen is in excess. Now, now you confirm what I just said now. Now, take for instance, let's take hydrogen as our standard. If you take hydrogen as your standard, 50, we require, it is 2 ratio 1. That means you have to divide by 2. 2 ratio 1, break it down to 1. So, 2, so 50 will require 25. And if you check, do we have up to 25 given? No. It therefore means that hydrogen is excess. Because hydrogen is taken as a standard, we will not have sufficient oxygen, and if oxygen is taken as a standard, we will have sufficient hydrogen. So it means that hydrogen is the excess, is the reactant that was in excess volume. So we don't use the excess reactant, we use the limited reactant. So the limited reactant is not taken as a standard. It therefore means that 20 will give me 40, because it's 1 ratio 2 bar, and 20 we require 40. Yes, 20 we require 40. So at the end of the day, you're going to draw a line. We're going to draw a line. I will call it remaining or residual gas. So after the reaction, what are the gases that are left after the reaction? So after the reaction, if you subtract 40 minus nothing, this is more like 0. 40 of water was formed. So if you do it, if the instrument used to carry out, used to spark gas in the laboratory, it's called a eudiometer. So assuming this experiment was done in a eudiometer, you observe that there's 40 cm cube of water vapor mixing with 0 cm cube of oxygen, because all the oxygen were used up. It is limited, as I said, it's a limiting reactant normally used up during the reaction. And we have about 10 cm cube of hydrogen gas left. So they ask you, what is the total volume of the residual gas? The total volume of the residual gas will be the remaining gas at the end of the reaction. So after the sparking, what volume of gases are remaining? That's the total volume of the remaining of the residual gas. So what we normally do is to add them up. So it will be 40 plus 0 plus 10. That gives us 50. So the total volume of the residual gas is 50 cm cube. If the question asks you, what is the total volume of hydrogen left? The answer will be 10 cm cube. If the question asks you, what is the total volume of water vapor formed? It will be 40 cm cube. So I will take this as case 1 for this reaction. One thing you should always know for this reaction is that you should be able to write out the equation pertaining the reaction. For jam level, it is usually, for jam level, it's usually these common reactions, either CO to oxygen and give me 2CO2. So jam level, normally these reactions, or H2 plus oxygen to give me H2O, 2 molecules. So for jam level, for most of the jam questions I've seen, they are basically of these two type of reactions. So you need a balanced equation to always solve questions on Gay-Lussac's law. CO is carbon 2 oxide, CO2 is carbon 4 oxide. So we'll move on to the next example. Quickly, we'll move on to the next example. All right, for example 2, you observe the question is quite similar to the first one. Now, it says 100 cm cube of oxygen gas is made to react with 50 cm cube of hydrogen. So oxygen and hydrogen reacting again. So back to this reaction. So through anhydrous was made to react with 50 cm cube of hydrogen, and pass the whole reaction mixture was then passed through anhydrous calcium chloride. What volume of gas is left? So what happens is that I tend to react hydrogen and oxygen. Okay, so pardon, because of because of um because of space, I'll require this. Okay, for space, I will need you to do this. So for space, I have to do this. So I have to do H2 plus O2 gives me H2O. Now, let me quickly explain something. Now, anhydrous calcium chloride, calcium oxide, H2SO4. When hydrogen is reacted with oxygen, what we normally get is water. When you pass the mixture over calcium chloride is going to dry the water. That means you remove the water from the mixture. So you're going to get water vapor, and it's going to dry the water vapor. H2SO4 is also going to dry the water vapor because these substances are deliquescent. they can remove water from the substance. H2SO4 is hygroscopic, so it can be used as a drying agent. Well, normally, when you pass this gas over drying agent, the product is usually removed. It's usually reaction of hydrogen and oxygen to give water. So it means that water will be removed at the end of this reaction after passing it through calcium chloride. So now let's see, hydrogen plus oxygen, you have water. So we have what now to balance the reaction here will be 2. Here is going to be 2 also. You saw the first reaction, it is similar to. So we have what's our ratio is 2:1:2. So no need to waste time. So what will be before reaction or before sparking? Before reaction, if RXN is reaction, before reaction, I what did they give us? Oxygen was made to react or is made to react. That means they've not reacted, but 100 cm cube is made to react with 50. So it means that 100 cm cube of oxygen is made to react with 50. And it should be noted that before reaction, the hydrogen gas, the product usually have no value. So what about after reaction? After reaction. After reaction, what will be the value? So after they've reacted, now before what will be the value of their volumes? But we need to know who is excess, who is limiting. So if 100 100 should be taken as standard, 100 you know is 1:2, that means 100 will require 200. 100 is taken as standard, we require 200. But we don't have up to 200 for the reaction. We don't have up to 200 for the reaction to work for 200 gas or 200 cm of hydrogen. Therefore, oxygen is therefore said to be in excess. Another way to do it, if you check the first video, 50 2:1. 50 will require 25. 50 requires 2 divided by 2 is 1. So 50 divided by 2 is 25. So 50 requires 25. Since 50 requires 25, since 50 requires 25, and 100 was given to us, it therefore means that oxygen is in excess and hydrogen is limited. Hydrogen will get used up before the reaction, before the by the end of the reaction. So at the end of the reaction, hydrogen will be completely used up. Oxygen will be remaining. So oxygen is excess. So now let's quickly go. So if you take 50 as a standard because it is limited, we are going to require 25. 2:1:2. So we're going to also produce another 50. So we're going to draw the line, yes, like that. So we're going to say this is remaining gas or residual gas. Remaining gas or left gases. So gases left behind. So anyhow you're going to put it. So let me not just stress the grammar. So anyhow you're putting it, it's still the same thing. So at the end of the day, if the remaining gas, what you just normally do is to subtract. So 50 minus, so it's going to be 50. The subtraction is not constant to some of us are going to be doing because this is 0 minus 50. No. Just find the difference. Just find the difference. So 15 minus that should be 50 cm cube. That's 50 cm cube of hydrogen is remaining in the mixture added. So this thing is done in the, let's say, in the gas syringe now. So it is a mixture, just form water. So the reaction has come to completion. 50 cm cube of water is there. Also, we have about 75 cm cube. 75 cm cube of oxygen. 75 cm cube of oxygen left. So the volume of oxygen left is 75 cm cube. So what's the volume of hydrogen left? It is 0 cm cube. So 0 cm cube. So 0. So it is 0 cm cube and 0 cm cube, like that. So now if you watch very well, remember the mixture was passed. Remember the mixture was passed over calcium chloride. Calcium chloride will remove the water vapor. So water vapor is out. Why is it out? Because it was passed over what's it called? Water vapor was passed, the mixture was passed over calcium chloride. Calcium chloride will dry water vapor. So the volume of the or will remove water vapor is going to absorb water vapor because remember it is anhydrous, it's not even yet hydrated. Anhydrous means salt that lack water of crystallization. So when they expose into the atmosphere, they are usually deliquescent. Calcium chloride is deliquescent. Magnesium chloride also is deliquescent. Those are examples of deliquescent substances. H2SO4 is an hygroscopic liquid because if you expose it to air or expose it to a mixture like this, done 3 times of its volume. So 50 cm cube of hydrogen of water vapor is left, is it has been dried off. So what is now the volume of gas left? The volume of gas left will be the volume of oxygen. volume of gas left will be the volume of oxygen. So the volume of oxygen is 75 cm cube. But funny enough, 75 cm cube is not in our option. Now let me check if it's a mistake. If it's a mistake, I have 70. I have sorry. Let me look for that question. I have 70. Oh, pardon me. I wrote wrong options. I wrote wrong options for the question. So if I should retake the options, pardon, should we take the options? The options are because I have so many of the questions in one of my questions here. So I wrote the question, I wrote the option of another question for it. So that was a mistake. Pardon me. Option A was 5 cm cube. Option A was 5 cm cube. Those of us in BPSA, this was your test question, question 19 in your last test. 5 cm cube, check question 19. You see that it was a mistake. So no gimmicks. So no gimmicks. So it was a mistake. Question 19, your last test. I will send when I send you the video, I'm going to send you the test question alongside question 25 option B, 75 option C, then 100 cm cube option D. So the answer is going to be 75 cm cube option C. These are the options. So 75 cm cube of oxygen gas, 75 cm cube of oxygen gas is left. Is left. So at this point in time, we'll call it a day. I remain your humble analogous, and I will see you guys in the next video. So make sure you like, watch, and subscribe. Make sure you subscribe. Make sure you subscribe. Share with your friends. Let them like it, and let's hit 2,000 views. So they'll share it with your friends nationwide. This over writing jam is a very key point. Very key point they normally test in the exam. So see you in the next video.